So what I'm going to do here in the next hour or so is I'm really going to use our company's experience working primarily with engineers and scientists in using techniques for prototyping applications as a way to reduce the risks of innovating and fostering innovation in a lot of different ways. Now, as I said, I think probably to really set this up, the background that I'm drawing from is not, as you saw in many of the other keynotes, a specific set of research or a specific set of clients that we research. It's really based on the experience of National Instruments as a company selling products to engineers and scientists who are continually innovating and inventing new consumer products, electronics devices, etc. And so it's really fundamental to talk a little bit about National Instruments, just to give you a background of kind of where I'm coming from and what are the types of companies that we work with that I'm going to be drawing my examples and my kind of tips and techniques for prototyping from. So we've been in business since 1976. We're based in Austin, Texas. A real homegrown success story there in Austin, which has become quite a technology center of note on the U.S. map. We have over 5,000 employees in 40 plus countries around the world. And we've been quite lucky and successful to have a very long-term record of growth and profitability over those 30 years, seeing the bump that everybody saw in 2000 and 2001, but continuing to grow to be an over $800 million company in 2008. And I would say that growth rate, that growth success has been no small part due to we are a company that has a great internal focus on innovation and invention and technology. And I thought for quite a bit that when we got invited to speak at this conference, I was going to spend some time talking about the way NI fosters innovation, because we have what we call a culture of innovation. And it's not just a process or a group, but it's really kind of a corporate way of thinking about the role of innovating and technology development that is really fundamental to the way our company works. But I decided I would rather let our customers speak rather than tell you about National Instruments, but I certainly would be happy to do that. But one indicator of, I think, of the importance of having a culture that supports and nurtures innovation is, for the last 10 years, we've been on Fortune's list of 100 best companies to work for, which is a fairly incredible achievement from our point of view, because most of those companies are people like the Container Store and everyday names of people that are kind of known as kind of consumer-oriented companies, but we're a company that is not a household name. We sell to engineers, we sell technical products, and so a lot of what we're doing is talking about how do we make engineers successful at doing innovation and prototyping. And I assume that most of you have organizations in your company where the engineers and the scientists are building the products and designing the products that you're hoping will be your next big success driver. So what do? We build products that let engineers and scientists test things. So we test cars, we test robots, we send experiments up in the space shuttle. We help engineers design things, do mechanical design, electrical design, we collect data, and we help people control things. And so basically, if your company has engineers and scientists using computers to automate any aspect of product development or design, you're probably using National Instruments products somewhere in that organization. And the real key is that our goal is to help what we like to call the domain expert be successful in innovation and development. So rather than the person who's an expert at embedded development, hardware design, electronics, a lot of what I'm going to talk about is derived from our goal to let the physicist or the biologist or the medical doctor get his idea to market in a successful and expedient way, not necessarily having the aid of an experienced, trained product engineer on his staff. So certainly we sell to probably all the companies in here. We have a customer base that's over 25,000 different companies. That is all of the, over 99% of the Fortune 500, and all the names that you recognize across industries, automotive, aerospace, petrochemical, etc. And we play a role in these companies in helping them test and design and get their products and their systems and their experiments to market and to productivity quickly. But I think probably what I'm going to use as a lot of the basis of today's discussions is not exclusively the work with these very, very large and well-known companies, some of which I think are on the built to last list, some of which have come and gone on the built to last list. But I want to use some examples of kind of current innovations and interesting companies and projects that we're working on that kind of form the basis for how we look at the value of prototyping and how companies of all sizes can use prototyping along with their other processes to reduce the risk of trying out new ideas, getting ideas in the market, and help balancing that with your more traditional product development process. So for example, we work with a lot of companies that are doing biomedical devices. It's one of the real burgeoning industries of people trying to take care of our growing, sometimes aging population, all the different maladies that are in our society here and around the world. So here's a company that was looking at this fact that over 200,000 premature infants are born a year in the US that don't know how to feed, don't know how to take a bottle or other mechanisms to feed. And so this company had the idea that maybe we could come up with a machine that could help teach a baby how to suckle. And so they immediately thought, well, we need to build a box that's a certain size and it's got to be a certain cost and we have to get it to market. So they went and they hired a custom design house. And the custom design house immediately goes through their standard process, charges their standard fees, and really wasn't prepared to work with the iterative creative process that's required to do innovation and try out new ideas. And these guys are people that were healthcare professionals. They were not embedded designers. But as part of the process of getting their ideas to market, they need a better way to be able to try out the ideas themselves. And so I have, through all these slides, as much as possible, scrubbed the NI commercial parts, but only wanted to leave some of the quotes from the people who kind of testified to the fact that when they went to a process where they were using rapid prototyping, where they could easily mix and match the pieces that they need to try out their ideas, they saw a much greater success rate of getting through the development process and getting something in the hands of the people who they needed to get to as their target audience, their venture capitalists, or what have you. So this was a very kind of touching and heartwarming story, but also a very practical problem that a medical doctor had an idea of how to solve. And he went to a process where he used off-the-shelf products to kind of build something that he could get in the clinics and try out. So at a totally other spectrum, I said that one of the big areas for us is medical devices. I would say by far the biggest area that we're seeing interest in people prototyping and trying to get new ideas to market is for alternative energy. And it runs the gamut from wind power to solar power to hybrid engines, and it goes from cars to home washing machines to solar powered, sprinkler systems in the backyard. And these are engineers and scientists that are trying to find solutions. And incidentally now there's also a lot of funding available for people doing alternative energy research, but it's not only the small everyday things. So for example, there's a private public venture to come up with hybrid electricity, hybrid engines for a steam locomotive. And a steam locomotive, if you live in an urban area, these locomotives or the diesel locomotives are still one of the chief contributors of pollutants in urban areas that have a lot of rail traffic. And so this is another case where the engineers had a creative idea about how to do hybrid electronics, but they had a very serious platform that they had to prototype on. They had this 10, 20 ton, 30 ton diesel engine that they needed to use as their experimentation platform. And so in order to try out the ideas, they needed a way to put the ideas in practice, but in a very safe, rugged, and reliable way.